So the company I work for Actis, has got a bit of a nice problem in that we've been quite successful and we've managed to buy other companies up and competitors and so on, which now means that we have sort of 20 plus products. They're spread all over the world. We've got different development teams, different languages and frameworks, and multiple data centers. So then we've got the problem that we've got our operations team who wants to make sure all our customers are happy and all our software is working all the time and we've got high availability and we can fix bugs and so on. And developers want to help them do that, but developers don't have access to production systems, and rightly so, which then means we need to have a good way of providing logging information so developers can go in, see what the applications are doing, work out why they've been failing or not working and improve them and so on. So we need to come up with some standard logging system which we can use about our group. So part of the group is already using Elasticsearch as part of their product, so it makes sense that we're going to look at using Elasticsearch. So tonight we're going to be looking at Elasticsearch from the point of view of sort of .NET developers rather than sort of an operations side. So who's used Elasticsearch here before? Anybody? Oh, a few. Good. Has most of you used some form of NoSQL database? Yeah. Okay. Excellent. So tonight we're going to be looking at sort of why not just use a normal relational database such as SQL Server? What does Elasticsearch give us, which something like SQL Server or Oracle doesn't give us? What is Elasticsearch? How do we get started? How do we install it? How do we put information into it? How do we get information out of it? Would it solve our problems? We've only got an hour to cover all this, so this is sort of like a getting started guide and introduction as much as anything. So feel free to ask questions as we go along as well. That's fine. So we've got an error. So, as always, the first thing you do when you get an error is you go off and Google something. So, or use Stack Overflow, find some code, because you're developers, that's what you do. So, you use Stack Overflow. But what happens then, if you lose internet, oh no, you can't continue. You've got no internet access, so how can you possibly write any code? So, being a developer, you want to come up with a solution for this. So what you can, no, I'll show you. So what you can do is you can download a copy of the Stack Overflow database. So you've got your local copy, and then you can query that. So then you don't need your internet connection to find your answers. So that's what I've done. So I've written a little application. So you can then go in and you can search for unicorn, for example. And it finds all your matches. So behind the scenes, this is using a SQL Server database. So hope you can see that there. So this is like a smaller version. I think it's only about 10 gigabytes in size, so it doesn't have all the data in. But you can see some example posts. Oops. So you can see the database they give you, you've sort of got the questions and answers and who submitted it and so on. But there's a few problems with using a SQL Server for this. For example, if we just want to do something simple, just like count how many posts we've got on our table. I was quite quick that time, but yeah, it takes a few seconds normally. So you can cheat and look at the indexes and so on to get a faster answer. You've also got problems that just, unless you start putting indexes on all the fields in your table. Oh. Yes, so for those who know SQL Server, it's going to do a scan, which means it has to look at every row in that table to find all the ones where the editor's name was David. And even if you did manage to create indexes on all these columns in this table, there's still some things you can't use an index for, such as this final example, which is finding any post, sort of doing a case-insensitive search for any post which contains C#. We'll see. So these are sort of typical problems we might have with SQL Server. So there's no real way we can search across multiple fields in SQL Server without getting really clever with indexes. We can't really search within a block of text in SQL Server. You can use things like full text searching, but it's got some limitations and it can be quite complicated. And SQL Server is quite hard to scale out across multiple machines if you want to be able to read and write sort of actively to multiple servers. So this is sort of where Elasticsearch comes to the rescue. So Elasticsearch you can really think of as being a NoSQL database, which is sort of designed for searching against in terms of storing lumps of text. So it's often referred to as the ALK stack, which is where E stands for Elasticsearch. So this is the main query engine, which is built on top of Lucene. And you normally access it using REST calls, so REST API calls, to read and write data. Then L is for Logstash. So this is a way of sending log files from your servers over to Elasticsearch. So they can come from Linux servers or Windows servers. You can look at IIS logs, Windows event logs, SQL Server logs, and so on. And then finally, the K is for Kibana, which is a graphical tool which comes with Elasticsearch, which sits over the top, and you can use for querying it and visualizing your data. Okay. So the easiest way to get started is to use a Docker image. So you can download a Docker image such as that one, and then you start it running. And you can see it has to use 3 different ports. So it's got 1 port for Elasticsearch, 1 for Logstash, and 1 for Kibana. So I'll just start that going. Going to run. This is the scary bit of the talk, because if Docker doesn't work, we're a bit of a problem. Okay, here we go. So it's almost there, I think. So getting started is pretty straightforward. If you've got Docker installed on your Windows 10 machine, you just download that image and start it running, and then you're ready to go, really. So like I said, you can connect to it using REST calls. So if we open a web browser, there it goes. So you can see if we, so Elasticsearch is listening on port 9200. So you can see it just gives you basic information about your Elasticsearch installation, such as the name of the cluster, you put it in and so on. So at the moment we've just got a cluster with 1 machine in. And you can see the version number, and behind the scenes it's built on an indexing system called Lucene, so it just sits on top of that. Right, so yeah, as I said, you can access it using REST calls. So I've written a little application which we can use for showing this. So the code's quite straightforward. We use a normal HTTP client. We connect to that local host on that port we looked at a minute ago, and then we're just going to be sending various get, put, post, and delete commands to that. So that's the first command we've already seen. So I've just sent an empty URL, and we get back that information about our cluster. So you've got other system commands built in, such as you can look at the health of a cluster, cluster health. And then that will tell you things such as how many nodes you've got and how many failing nodes. And you've also got this status, which can be green, yellow, or red, depending on how many nodes are working and so on. So the first thing you want to do is actually put some data into your Elasticsearch. So you can add a document. So I'll run that first. Okay. So there's a few things to note here. So to add a document in, I'm using a put command, and I send and the body of the command is the document I want to add. So that's a schemaless JSON document. So I could put anything in that box. I didn't have to declare that first. The URL, you can see, is made up of 3 bits. So we've got an index, a type, and an ID. So the index is meetups. the type is .NET Sheff, and the ID of this record is Oct 2018. And you can see the results that come back also show you that information. If I put the same document in a second time, you notice it now says it's been updated and the version number's increased. So I can just keep adding in more versions and it's going up. To get the data back out again, it's the same sort of idea. So instead of doing an add or a put, this time we're going to do a get with the same URL. And we get our document back again. And so the source here contains our document. We've got our index details there and which version we're on. So unsurprisingly, we can add another document with a different ID. So this one's obviously version 1, and we can pull that one back out as well. One of the slightly strange things about the way the Elasticsearch REST calls work is the specification for them is quite often using a get command, but actually passing a body of JSON, which things such as HTTP client doesn't really support. Normally when you do a get command, you're not passing a body. So they've had to add some additional verbs so you can do put and post in those cases. Right. So we've seen putting stuff in, we've seen retrieving it back out, so you can also delete documents. So again, same URL, this time the verb's just delete, and it's told us it successfully deleted it. If we ran it a second time, it says it didn't find it, so it couldn't delete it. Okay. So the next thing to explain really is, so I've mentioned this URL's URL's made out of 3 things, the index, the type, and the ID. So you might expect that in that case you should be able to, if you wanted to store different information in your index, you might be able to keep the index the same, but change the type and give it a different ID. So now instead of putting in .NET Sheff, it's got a Code Dojo in York. But it turns out you can't actually do that anymore. So this is something Elasticsearch used to support. So they used to have the idea that the first part of the URL, the index, was equivalent to a database, and the second part, the type, was equivalent to a table. But then they decided that isn't really how it sort of works internally. So you're better off thinking of it being the meetups part at the beginning is really the table. So that represents what a traditional table is. And the type bit is more of a filter of rows within that table. So they all have to have the same structure. So you can't have some documents with some values and some documents with other values. So so we didn't set up anything in advance. So when we added that first document, it automatically created the index and the types and so on. So we can go in and explicitly then remove indexes. So this, I'm using the delete with the meetup one. And that will delete that whole index and any documents associated with it. And if I ran it a second time, you see I get the error saying that index no longer exists. Okay. So is everybody happy so far with sort of how the basic REST commands work? And, okay, that's good. So up to now, we've just been adding records individually. In real life, you probably wouldn't want to make that many REST calls in order to add lots of documents, so you want to try and do things in bulk. So there's also a bulk API. So here it consists of 2 bits, really. So the first line says create, so that's what we're trying to do. We're going to try and add this document. The second line, which begins title, is the document we're going to add. Then we're going to try and create another document, which is that one. And then we're going to try and create another one, which is that one. So in this example, we're trying to add 3 documents that don't already exist. It's quite fussy. So if I delete the carriage return on the end and then do execute, it actually errors and says it has to end with a blank line. And if I missed out some of the carriage returns between those lines as well, it'd also error. I'll put that back in. Okay. So you can see everything's at the top. So there's no errors. That was the result of the first sort of insert. second one, and the third one. So all 3 creates worked in that example. If we then ran it a second time, you see now we've got errors because we were telling it to go off and create this document, but they already exist the second time we ran because it has the same ID, so all 3 of them are already there, so all 3 errored. So the solution to that is instead of using the create command, you've got some other commands. You've got index, is that thing at the top left there. So that means create the document if it doesn't exist, otherwise update it. Delete, which means delete the document if it already exists, or update, which means update it if it already exists. So you can see all 3 of those worked. But if I ran that a second time, oh, it works as well. Yeah, so the delete then failed the second time because the document didn't exist. Okay, so we also have is I've written a little program here which is going to take our data out of our SQL Server database, so logs into SQL Server, and then it just starts loading into our Elasticsearch down it, database as bulk, so it's using the same sort of create index commands. So I'm just going to start that running because that takes a couple of minutes to complete. Make sure that's working. So yeah, so it's loading documents, 10,000 documents at a time. So just get that going. So yeah, so we talked about adding data in and getting back single records, but you can also do searching because that's really what Elasticsearch is designed for. So we can use the search URL, which will just search over all your indexes. So you can see it, so it's found some of the Stack Overflow documents we've already added as well. A second time. So you can see the number of hits is going up as there's more documents added in. And yeah. So you can also, instead of searching over all indexes, you can just search across a single index. We'll just look at the meetups index, which was the ones we used the bulk API to load. So you can see we only get 2 of those back. Or we can get fine and grained and do a type within an index as well. But then you can also start providing queries and Boolean logic when you do the search. So instead of bringing back everything in the index, I can just bring back any meetups where the speaker has the name Kevin included. So that record matched because Kevin was found in that speaker's field. So when you load it, by default, when you load data into Elasticsearch, it looks at your English text and analyzes it and splits it up into different words. So then when you're doing a search, it uses sort of a back to front index. So it can easily find just like single words within a string. So because you can do Boolean things, you can also put in the operators. So there's no match on Kevin Betteridge because we don't have a speaker which has got both Kevin and Betteridge in the name. So change it to me. But here this is matching because we've got a speaker which contains both those words. So it's not querying for the string David Betteridge, it's querying for the string that contains David and contains Betteridge.
Can you swap them around and prove it?
Yeah, I hope so. I know. Fingers crossed. Yeah, there. Okay. You've done that one. So, yeah, so I'll go back to that again. Yeah, so when you do it using the match command, that's sort of our fuzzy search, almost saying, that has to appear somewhere in this string, we don't know where. When you're using term, it means it's an exact match. So the speaker field has to contain exactly Kevin Smith in order to get a result back. But the reason we don't get any results back is because when we loaded the data into Elasticsearch, by default, it split that up. So it hasn't actually held it as Kevin Smith. It's held it as two different values at this point. So I'm saying, find me a speaker which it matches exactly Kevin Smith, and we won't get a match because we've got one field that contains Kevin somewhere, and we've got one that contains Smith. So if I change that back to Kevin, oh, we don't get a match. So the solution to that, well, first of all, we'll look at mapping. So when you load data into an index, it also creates what's called a mapping, and that shows you the fields it's storing and the types of data for each one. So as you can see here, it's where's it gone? Speakers. Yeah, so it's decided speakers is a text field, but it also creates what is called like a keyword field, which is the original version. So if I use speakers.keyword instead, it then will match, because that is how it's storing that data. Okay. So this time, fingers crossed, it won't work if we do it the other way around. Yeah, okay. Does that make sense to everybody, sort of the difference in how Elasticsearch is working there? Okay. So So although it generates this mapping automatically when you first create the index, you can provide your own mapping field. So when you're loading a larger document, you might know which fields you are actually going to search on and which you aren't going to search on, and which it makes sense to analyze as English or language text, and which it just doesn't make sense. Something like a town, for example, you'd probably just want to always load as a keyword. You wouldn't be interested in splitting that up. So in terms of using this from .NET, this is obviously a fairly sort of low-level client. So all we're doing is just sending REST calls. So we're just sending HTTP requests over to Elasticsearch, and it's responding, and we're just sort of displaying it straight back on the screen. So there are some libraries available to make it a bit easier to use. So the first one is the Elasticsearch.NET client. So this is a NuGet package you just install. And then within your code, you can then instantiate a client object, and you pass in various settings such as the the various Elasticsearch servers you'd like to connect to. And then you can create objects in your code and then pass that whole object to be indexed, and then you can either get bytes or strings back. So the point is, you're no longer having to pass the JSON yourself. You can say, here's an object, please go ahead and index it, and then it can give you back a response. So it's a bit higher level. It handles things such as if one node in the cluster fails, it can move over to another node and so on. Let's just start that running. So you see the same sort of thing. I can insert data. There's asynchronous versions, and you can do searching as before. And if I just open Fiddler up, So you can see it's behind the scenes, it's sending the same sort of JSON commands. So all this Elasticsearch library is doing for you is just writing the HTTP commands that you're going to send backwards and forwards. And you can see the response comes back just as JSON again. So that's quite a good library to use. But the problem is you're still just giving it an object and it gives you JSON back, so it's not very strongly typed. So there's another library which sits on top of that one. Which is called Nest. Okay, so yeah. So again, it's a NuGet package called Nest, and it's got dependencies on the other library, which is the Elasticsearch.net one. So it brings that one in for you as well. So it's the same sort of way to use it in that you create a connection object and you pass in various information such as the endpoint you want to reach, so the URL, which index you're going to use by default, or you can provide it in your query. And then when you start actually doing the search, it takes in a type, which is the type of object you're expecting back, which then means when you're writing your query, you then get sort of type safety, because it shows you all the properties of that post object. So I'll show the poster. So this is a Stack Overflow post. So you can see it's got title, body, editor, and so on. Yeah, so you can see it's running that command there. So you can do things such as when you write in the query, you can change how many results you expect to get back, and so on. You can search for something different. And just as before, you can see just as before, all that client's doing is just writing these queries for you. But it just gives you a bit more type safety this time, because you're actually saying, I'm going to get this object of type post back, and so they're the fields you're allowed to query on. So then you've got various commands, such as if you want to match everything on the index, so you can use match all. You can do fancy things such as ranges of dates, so that's a date search, so everything between 2000 and 2018. Or you can get more and more advanced, where here I'm saying it's a Boolean condition, so the owner is David, and also the last editor is also called David, plus I'm only interested in things which are filtered in that time. So you can get more and more complicated queries. And yeah, that's so we just go back to the REST calls. So you've got other commands against an index, such as statistics, so you can see how many documents are on an index. So you can see we've loaded, what's that, just over 3 million Stack Overflow entries, and you see the size and so on. And view the template or the mapping it's created behind the scenes. And then we can do searches against our Stack Overflow data as well. So yeah, so we've looked at getting records back and doing normal sort of searches. We can also do aggregations, so you can do things such as how many entries were created in each month. So we scroll down here. So it brings back buckets of results. So it's saying in December 2009, there was 136,000 records. So if you're doing that sort of information, you probably wouldn't want to return any search results at the top, so you can then set the size when you're doing your search to 0. And then you just get back those buckets of data. So you can use that in various ways. You can do sums, min, max, rolling averages, and so on. So this is a rolling average. So that's all quite powerful, and there's, yeah, takes quite a long time to sort of get your head around all the different combinations, but it seems most things you can do. So we've looked at those. So sort of to summarise that really, I guess, is at the lower level, you're always using REST calls, and then they give you an Elasticsearch library, which sits on top of that, which generates those REST calls, or you can use the Nest client, which then in turn uses the Elasticsearch library to generate the calls. So any questions so far? Is everyone sort of happy about sort of basic use? Okay. So it's just about finished loading, I think. So now we've got the data in Elasticsearch. It meant I could have, I've gone back and I've updated my Stack Overflow application. So I'm now using that Nest client to log in, as we saw in sort of the examples earlier, and I'm using that to do the searching. So that's now searching against Elasticsearch as opposed to before in its SQL Server. So Elasticsearch also gives you other nice features, such as you can do highlighting on the results that come back, so it can show you how it actually found your result. And so on. You can also do something called scrolling, where you can say, I'm going to want to get my results in batches, so you can get the next batch, and so on. I don't know why there's so many questions with the word unicorn in. The SQL as well. And you can change the number of results that come back and so on. Another way of looking at it, like Google, is it's really a sorting engine rather than a search engine. So it would find which results has the highest sort of ranking or highest score, and it puts those first. So when you're looking at the data that's coming back, I don't know if I can see it. Don't know if we can see it in here. Each entry gets given a score. I don't know if you can see that there. And so the higher the score, the better the match. So, I haven't got any examples here, but sometimes you might search for something and that string might not even be in the search results, but it just be its closest match. So you can, when I had that Boolean logic before, I was saying it must contain this and must contain that, but you can also do things like it should contain this and it should contain that. And you can also say that it's more important for it to match on first name than it would be to match on surname, and so on. But yeah, it's easy to think of it as a sorting program rather than a searching program, and you're using it like that. Okay. So we looked at Elasticsearch. So one of the next things you could look at is Logstash. So Logstash is written in Java, so you have to have the Java runtime installed to use it. And it's quite good in that you can give it various files, and you can give it a definition file that says, these are the columns in my IIS logs, for example. Please load those into Elasticsearch, and it loads them in, and you can query them. One of the disadvantages is that you do have to put the Java runtime on your server, and being .NET developers, we don't necessarily have that on there, so that might be an issue. There's also something a bit newer called Beats, which is a bit more useful for Windows. It's written in Golang, so there's no sort of Java dependencies. And that understands things directly, such as IIS logs, so that's already built in. So I'm not going to look at those today, because that's more of a sysadmin thing rather than a .NET developer thing. So we'll look at some ways of getting sort of logging out of code in a second. So then K is for Kibana. So this is the graphical dashboard tool that sits on top. So I'll show you that. That runs on a different port, 5601. Okay, so the first time in, because we just created a new Docker container when we hit here, so we've got no data set up, there's no indexes defined. So at the moment, Kibana doesn't know anything about our setup. So the first thing you do is you go into management and you say which indexes you're actually interested in visualizing. So down here you can see it's found the indexes we've been using because we loaded some meetups and we've loaded the Stack Overflow data. So what we do is we're creating an index over the Stack Overflow stuff at the moment. Oops, Overflow. So it allows wildcards because quite often you might create one index per day or per month. So you'd start it, for example, Stack Overflow hyphen and then today's date or the beginning of the month. And so you can do star, which then puts a visualization over all your indexes. It's a good idea to have some sort of time field in your index because then you can do graphs based around time. So it asks you which is that time field. So we'll have creation date. Okay, and then it's automatically detected the fields which are in that index. And you can do customizations here. You can put extra computed fields in and so on if you wish. So now, the first thing you probably want to do is actually look at some of the data. So we've picked our Stack Overflow index we've just created. But as you can see, it hasn't found anything because it has a time filter as well. So it's quite nice. You can easily click to say, you know, I'm interested in things that's happened just today or in the last couple of hours, the last 10 minutes or so on. Because this Stack Overflow data is quite old, we have to actually put a date in. Okay. So here we're looking from 2010. So you can draw over the graph and it adjusts the time frame for you. So you can zoom in. So that's quite nice in itself, just to give you a bit of a shape of your data. If you're looking at something like log files, and you might suddenly see a whole spike of invalid logins or something like that, and then you can home in and you can see what's going on. So we noticed that with some of our production servers, there's some massive spikes. We looked at it, and it was people running automated sort of, you know, SQL login attempts against our software. So they really stand out. Something if you see a spike on a weekend or a bank holiday or something, you think, well, that's a bit strange. And then underneath are the records it's found that matches it. So you can expand each one, and it shows you each of the fields. And then you can include them in the table if that's something interesting. So you can click that. Yeah. And then you're creating a table with those two columns in. And then you can do things such as, I'm actually only interested in posts made by someone called Chris. So you do plus, and it adds a filter. And it shows you all on like that. And you can say, but I'm not interested in Chris' job. So you can filter that one out. And you see at the top, it's creating these filters for you. It's quite nice. So that's quite a nice, fast way of sort of analysing your data and looking at it. You can also do visualizations. So we might do something like a metric. You pick your index. So that's a count of all those documents between those times. So if I change the time. Yeah. And then you can save that away. So it can be count of all posts. do other visualizations. So we might want to do by person. So you can add a pie chart and then pick which field you're interested in. So you can then start to see, who's created the most posts and so on. So these are both questions and answers. So you want to add a filter. So you can say post type keyword is when you're interested in people who've answered questions, maybe. And then you can start to see who uses Stack Overflow the most and so on. And then you've got various visual options and labels and so on, sort of things you normally expect. So again, we can save that away. And another quite interesting visualization is a tag cloud. So each question has some tags with it, which says which languages it relates to and so on. So we can map them. So, log and I'll work out to this. Yeah. And we'll probably want more results. Yeah, so you can then start to see, which questions have had which topics are the most interesting questions. So there's obviously been a lot of C# questions and Java and JavaScript and less Link and Eclipse and so on. Save that as well. So then when you've created all those various visualizations, you can then stitch them together into a dashboard. So you can see, and then we can then save that dashboard away as well. So you can see with a few mouse clicks, it's quite sort of fast and easy to visualize your data and have some idea about what's going on. And then with these dashboards, you can then share these with your users and not give them access to anything else other than just this dashboard. So they can't actually create their own and so on. Yeah, so we've looked at it in terms of being a document store. So the other common use for Elasticsearch is for logging. So you want to actually log events from the application as they take part. So the thing I use is Serilog. So I don't know if many of you use that logging framework before, but it's quite straightforward to set up. So again, you've got some NuGet packages to install. So you've got various ones. So the logging framework itself, the fact I'm using it with ASP.NET Core, and also the add-in to allow it to use Elasticsearch as well. And then in your startup code, actually, in your startup code, you don't do anything. In your program start, you set up the logger. So you can say, I'm going to get my logging information from a configuration file, so the app.settings file. And then you log a few events such as it's starting. And then you do logging in your code as normal. So you inject an object of type iLogger. And then you can use that to log information. And in app.settings, you say you're using that logging framework, and I'm saying I'm going to write to Elasticsearch. And that's the URL of Elasticsearch I'm going to write to, and the index I'm going to put my data in. So you can see I'm creating a different index for each month as well in that example. So back in the logging code, see that. You've got two ways of logging, really. You can do a straightforward message, such as that one there. So that's just going to write the message. This is a message. And you can also do structured log entries. So you can see you have a template where it says this is the message, and there's a few parameters: module, user, machine, and those are the values I'm then going to provide to those parameters. So it's a bit like how string.format used to work, but you used to put numbers in. Here you can actually name the parameters. So if we just run that, and we just okay, I'll just refresh that page a couple of times. So now we can go back into Kibana and create another index. And you see it's created our index.NET Sheff. So here I can use the wildcard, so I don't have to fill the date in. So I'm going to just look at that index instead. So now we can say I'm only interested in stuff in the last 15 minutes. And you can, these are the records we've added. So that was the message I was doing with the structured logging, and you can see it's filled in the values for me. So that was the template it was using. So it's done two things. It's filled the values into the message itself, but then it's also created additional fields which just contain those values, which is quite nice, because then you can then start sort of searching on, is it that one? And so you can then pull those out into the table, and then you can do searching. Just say find only the entries for user David. Any questions around that? Really? So built-in events would get logged to it as well. So when you spin up a ASP.NET website, it creates a lot of events itself as well, so they all get logged by default unless you turn them off. So a final couple of things. Security. I guess from the Microsoft world, things seem to be secured by default, and you have to enable it. So things such as, by default these days, firewalls are on, you have to allow ports through and so on. With Elasticsearch, it seems to be the other way around, so everything's open by default, so you then have to go in and secure it and work out how you're going to restrict access to Elasticsearch and how you're going to restrict access to Kibana. There's an add-in called XPack, which helps with some of that sort of stuff, and there was a charge for it, but now I think a lot of that's open source, so that's one way of doing it. Or you can just not expose the APIs, the endpoints, directly to users. You can put a gateway in front and use that to authenticate. So like Azure API gateway, that type of thing. Scaling works in two ways. You can shard your data, so you can put some of your data on one node, one server, and some of your data on another node. So then you can read from both at the same time, so that speeds up performance. And you can also duplicate data for sort of fault tolerance, so it can be written to more than one node. So I'm not going to go too much into that today. I think that's so sort of finally, yeah. So hopefully we've sort of looked at some differences between SQL Server and Elasticsearch, and we looked at various ways to load the data in and how to get data back out and visualize it. So I think that's about it, really. Okay, that's me done then.